In this video, I will show you how to obtain scientifically valid photometric data from your images using ImageJ. The prerequisites for this video are that you have already installed ImageJ and the astronomy plugins. If you have not done this yet, details of how to install the software are given on the reddots.space website. You should have already captured the relevant calibration frames, bias, darks, flats, etc. for your equipment. Again, details for how to do this are given on the reddots.space website. Okay, now assuming you have completed the prerequisites, let's have a look at how I've set up the directories for the calibration files. So here's the directory, and it contains a directory called bias, where we have the bias frames that you will have taken. Now the bias frames are the 0-second exposures. The next directory is the calibrations directory, which contains the directory where all the master calibration files will go. Then we come on to the darks directory. This contains the dark frames that will have been taken. The dark frames are exposures with the shutter closed on the CCD and have the same integration time as the light frames. Now moving on to the darks for flats. These are the dark frames with the same integration time as the flat frames. And flats, this directory contains the flat frames. The flat frames are images taken of either the twilight sky or of the dome roof in white light. Flats will show up, for example, dust on the CCD chip and any vignetting in the system, and are used to remove these effects. Next directory is the lights directory, which contains the images taken of a star which have not yet been corrected with the calibration frames. And finally, the science directory, which is empty, which will contain the corrected calibration frames. The first step is to create the master calibration frames from the calibration frames we have captured as part of the prerequisites. The first master calibration frame to create is the master bias frame. Firstly, we'll start up ImageJ by clicking on the ImageJ executable, which I'll find in the ImageJ directory. So click on that. So that brings up the smart icons and the menu bar. And now what we're going to do is we're going to load the bias frames. And the way we do that is we go File, Import, Image Sequence. And we select the bias frames directory. And we select Choose. And this shows us the number of images in the directory is 10. And I have 10 bias frames in there, so we'll just click OK. And they'll load up. And the next step is we'll have what we see on the screen is black in terms of what the bias frame looks like, and that's because the contrast and brightness is not at the right levels for us to see the details in the frame. So we'll just go and we'll adjust the brightness and contrast, and we'll just can move it brightness and contrast. Yes, that looks good, and we can see the details of the bias frame there, and we can also see that the CCD I have has got a column defect here, which is this bright line going down here. And what we can do is with this scroll bar at the bottom, we can go back and go forward and back, and this is taking us through the different bias frames. Okay, so now we're going to create the master bias frame. So the way we do that is we select plugins, we select CCD, and we select create master bias image. And this will create the bias image using the stack that we have. And we can enter the name here of the file we want to create. I'll just leave it as bias.fits. Press OK. And there it is. It's create the bias.fits file in the background. And in the foreground you can see a log, which we can scroll through and look to see if there are any problems with it. But no, it's just gone through and it's created the 10 bias frames and said finished at the bottom. So we can close the log file. And the final step now is we'll take the bias frame and we'll save it into our calibrations directory. Now we'll save it as a fits image, and we'll save it into our calibrations directory. So here, and save. So that's the master bias frame done. Now I'll leave that open, but what I will do is below that you can see the image sequence for the bias frame. So I'll just close those and then we're ready to move on to the next step. Right, now we're going to create the master dark frame. We load all the dark frames by selecting from the menu bar File, Import, Import Sequence, and we go to the darks directory, which is here. Select that, select Choose, and we have 10 darks in the directory. Press OK, and the 10 darks are loaded. Again, we need to change the contrast just to see the details. So I'll do that image, adjust brightness contrast, and bring this across. We can see some detail there in the dark. You can see a little cosmic hit here, and we can move between the different frames again. As we do at the bottom, you can see the cosmic hit that was there has disappeared, and forward and back. So, okay, now we have the frames loaded. Now we want to create our master dark, and again to do that we go to the plugins, CCD, create master dark image. And here we're asked to put in the bias image, which is bias.fits, and we're going to create the dark, which is we're going to call dark.fits for the master dark. And press OK. And it processes it. And there we have a log file, and again saying it's successfully finished. So we'll close that log file, and the master dark we will save to a fits file again, and we're going to save that to the calibrations directory. And we'll leave the darks file open, but we'll close the image sequence here. So we'll close that. Won't save any changes to it. And that's that step done. Now we're going to create the master dark for the flat frames. And it's just a repeat of creating the master dark frame as before, but just using the dark for flat frames. So again, we import the image sequence. We go File, Import, Image Sequence. This time we select darks for flats, hit Choose, and there's actually 13 here this time, and we press OK, and they're loaded up there. And now we'll create the master dark for flat, which we use the plugins, and then CCD, and create master dark image. And the bias frame will keep the same as bias, but the dark we'll call dark for flat. Press OK, and it processes it. You can see the bar here, which is showing the progress on processing the files. And there's the log saying we're successfully finished. And it will save the file as a fit file. To the calibrations directory. It's done, and we will close the image sequence. Which is this one. Right, now we're ready to create the master flat frame. So again, we have to load the flats in, again in this sequence. So File, Import, Image Sequence, and select the flats directory, Choose, and we have 10 flats in there, and we load them in, and there they are. There's the image sequence. So in order to process them, we go to Plugins, CCD, Create Master Flat Field Image. So what we're going to do here is we're going to do bias correction with the master bias frame, and then we're going to apply the dark correction with the dark for flat, which we've already created. And the flat field image to be created we're going to call flat field.fits. Press OK. And there we have it. The master flat's been created, the log file says it's finished successfully, and we'll close that and we'll save the flat file to as a fits file again to our calibrations directory. And then we'll close the sequence of flats. Right, now we're going to convert the lights into the science frames. So the way we do that is we open the image sequence for the lights. So we go File, Import Image Sequence, go to the lights, and select a directory. We've got 10 files in there, and hit OK. And we can have a quick look by doing image adjust brightness / contrast, and to see if there's any details of the stars in there. There we go. And what we're going to do now is we're going to process them by going to the plugins item on the menu bar again, going CCD, and then process images. Right, so what we're going to do here is we're going to subtract the bias image using the bias frame we've got. We're going to remove the dark current with the master dark frame we've created, and then we're going to divide by flat field with the flat field image. And we're also going to remove the cosmic ray hits, so we select that option, we'll press OK. And now processing is underway. And we can see the processing happening up here as it does the different operations. This takes a couple of seconds because there's quite a lot of processing going on here. And there we have the process lights, and again we can go to image, adjust brightness, contrast to see the, so we can see the stars. Just there we are. Okay, so we're going to save those. Save as image sequence. Format is going to be fits. I'm going to call them science. OK. And we'll save them into the science directory. And we'll just close that sequence now. Right, now we're ready to do the photometry. So the way we're going to do that is we're going to firstly load in the science images. So we go to File, and then we go to Import Image Sequence, and we're in the directory of science images, so we choose the directory. There's 10 science images in there. We press OK, and they load up, and we can have a look at them. We can change the brightness and contrast so we can see the actual stars. So I'll just try and do that now. Right, a bit more. and there they are. So this is our target star, and this is the comparison star here that we're going to check against. Okay, so how we do the photometry is we will use the plugin. We'll use a plugin first called Set Aperture, which is in the astronomy plugins, and Set Aperture. And you can set the apertures, which are the 3 concentric rings round the star, the size of them in this dialog box. So depending on the setup with your system, you'll need to change these so that they'll fit. I've chosen 25, 30 and 35 for mine. I'll show you annuluses in a second. So press OK. So we have that there. We don't need to set anything else up, and now we'll move on to doing the actual photometry. So again, plugins, astronomy, multi-aperture, because we're going to do multi-aperture photometry because we've got the target star and the comparison star, and here we need to set the number of apertures per image. We're setting it to 2 because we have the target and the comparison. First slice is the first image 1, and last slice is 10, so we've got 10 images in the directory. And then what we'll do is select these options here. So we have all measurements from one image on the same line. We compute the ratio of the first aperture to others, which is what we'll do. And we'll show the total comparison star counts and the error of the ratio, and also the signal to noise for information. Press OK. Right, okay, so this brings up a cross here, and we go and click on the target star. There we go. It's a nice green set of concentric rings here. There's 3 of them, and then we'll go and click on the comparison star, which is here. We'll click on that, and it's processing them, and that's it. It's done. It's done the photometry. So, right, so just to explain what this measurements here, this is the log file that's created with the photometry measurements in it, and we have numbers 1 to 10, which shows us our 10 images, and this is the name of the files that the images that the data is derived from, the 10 science frames. Slice again is just from 1 to 10, which is just the image number in the sequence, and then we have the coordinates, which isn't that important, source minus sky. What we're interested in collecting though, and moving across to the AAVSO data file, is the Julian date here, and we have to remember to add the 24 times 10 to the 5 onto this number, so we need to put the 24 in front of the number when we move it across. We have to remember to do that. And we can bring across the air mass as well. If you've got the air mass recorded, then that'll be in the FITS files, then that'll be brought across as well. And then this is the important bit here. This is the ratio between the target and comparison star, which we need to bring across, and you need to multiply that by minus 2.5 times log of this number to bring it across. And then we're going to bring the ratio 1 error across, and that goes into the magnitude error. So ratio 1 goes into the magnitude field, and ratio 1 error goes into the magnitude error field. And those are the mean fields that need to be brought across. But you can see you've got the signal to noise ratio here, which you can see. So you can see what sort of signal to noise ratio you've got from your measurements. And that's probably about all that we need to talk about now. So that's it then. That's basically how to reduce your data and to create the photometry record and do the photometry measurements, and the data there you can just copy across into your AAVSO file, and then you can upload it to the AAVSO database.